Well, going a bit deeper into more details in this room, I think a great example is the door surround behind us, which has amazing columns. There's several ways of actually making these columns, but it looks one gigantic solid piece of mahogany, but it actually is not. It's actually, they call it, well, one of the techniques is coopering, whereby they just use solid parts, join them together, and then on a large lathe, they could have turned this actually most likely on the lathe, because there's a very slight taper like in any classical column, and they would have glued those sections together. So sometimes you have horizontal sections, but in this case it's actually vertical strips that are actually all glued together to form a full circle, and that circle is then on a lathe turned on a rather large lathe to actually form this very, very subtle taper, which you can actually see if you look very carefully, based on pretty much the classical proportions. And again, mahogany is a fantastic material for that, because it works so well, and you can imagine you need a great accuracy to get all those segments all glued together into one full circle. And mahogany is one of those amazing timbers to actually, you can plane it to absolute perfection. The same with carving. The capital above it is carved to an exceptional detail. And mahogany is one of those very good timbers that can be carved very well. Because it is hard, but with a nice sharp tool you can get very fine definitions and very fine details in it. And the fine grain as well will help to go very, very, very detailed. Most of it is hollow actually. So because the material was so expensive, very often they would have made the carcass out of pine and just glued on sections of a couple of millimeters of timber, in this case mahogany, and then molded that, or veneered areas. Because nowadays veneer is often regarded as inferior, but of course in those days veneering was something more superior, because you would use a substrate or a timber underneath, but the veneering was a lot more work, and the veneer itself was a lot more precious. So to do something in veneer would have been in the 18th century a lot more precious and expensive as it is now. Okay, so we have here a pediment. This particular pediment is from Russborough, and you can imagine this sitting on top of a door. How this is built is actually very interesting. Again, mahogany was a very precious material, so they tried to save as much as possible of this precious material. And then all of these components would have been put together, most likely again because we had a lot of doors in the house. They would have had some kind of a serial production going. So there would be joiners who would just plane this, because it's planed on this side but it's kept rough on the other side. Then they had people just gluing bits together. Then others would actually cut this all up and then nail the components back together. And then maybe the more qualified people would actually make the moldings and work with the more expensive materials. You can see here as well, there's some drops here of the glue. So they used an animal-based glue, so that would have been made out of collagen or a hide, most likely. Sometimes they're made out of bone as well. And this collagen is a natural polymer that melts at about 45 degrees. And that gel then is very, very sticky. The problem is as soon as it cools down, it gels. So you have a very small window of opportunity to put the two parts together before the glue starts to gel and starts to harden. So you have to work quite fast, or you have to preheat parts to actually extend that open time. But as you can see, the glue is still working really well, and again the Egyptians used the exact same glue, and that has lasted for thousands of years. So it's great to have it actually done, and as you can see, the back is a lot more interesting than the front. It's with most historic objects, I think the underside of the back of objects is a lot more telling than the actual front or the decorative part. It also shows that it's all about the illusion of it being solid and being very fancy, but actually we just have a bit of pine here nailed together with a couple of nails. Halfway up the staircase, on the beautiful mahogany staircase, and this is part of the paneling around the staircase. And what's really interesting, because it's actually broken, it gives us a lot more information about how this was actually constructed. So the maybe should go a step back. The whole purpose of a panel and a framework is to cover a large area of wall with something pretty, but also practical for insulation. And as we all know, timber moves all the time. So if you would just use solid planks and nail them to the wall, they would all crack and move all the time. So to avoid that, somebody very smart came up with the idea of let's make a framework around it. So this is jointed like a mortise and tenon there as well. This goes in here. So the horizontal member has the tenon, and the mortise, which is the hole, is in the vertical style, and they go together. It's unlikely that they're glued, but to keep them together, they put little pegs in here, and these pegs are like a little lock in the mortise and tenon to hold them in place. And before they put this all together, they run a little groove with a molding on the outside, and in that groove sits this panel. And as you can see, these are all still loose, so they wouldn't be glued inside this groove. And what happens, so if this timber expands or contracts, and again, as we've learned before, it expands and contracts more in width, very little in length, and a tiny bit in thickness. So as you can see, this has moved a bit more. Maybe I can get this even back into its original position. So this is very close to its original position in this area. So the panel is tapered, and that's why it's called a fielded panel, because this is the actual field, and the edge is tapered downwards to make it very thin. And this one is about 2 millimeters thin at its thinnest point. And that thin bit sits in this groove in the frame. And so when the timber expands or contracts, it has this opportunity to actually move within the frame without being restrained in its movement. And that's why it shouldn't crack. In this case, the joints cracked because possibly of moisture in the wall that actually dissolved the water-soluble enamel glue in here. It could also be that at some point it got stuck and the timber expanded and couldn't freely move, and that caused the weakest link to break, which is the joint. What's quite interesting here as well is that these two planks are mirror images of each other. So this is a book match. So these are the two consecutive planks from the tree. So obviously they kept those planks together, and when they made this panel, somebody decided to have this mirror imaged or use the same position of the two planks to make this panel, which is very, very pretty. And again, it would make sense because you would walk up the stairs and the first thing you see, if you actually haven't noticed the stucco work, would be actually this panel.